AWS EMR Service Hands-on Demo Advanced. In this section, let's look at some of the advanced capabilities of AWS EMR Service. So what are the objectives? We're going to look at how to create a cluster using some of the advanced configuration options. Then we'll also try to scale the cluster. We'll try to scale up, and we can also scale down the cluster, including the core and the task nodes. And then finally, we'll try to log into the master EC2 instance so you can even do more interesting things hands-on inside the cluster. All right, let's get into the live demo. I'm back again into my AWS EMR console. Let's go ahead and create cluster. Notice we explored the quick options. Let's go ahead and explore the advanced options. We are in the advanced options, and let's explore that. Let's go ahead and create a cluster. We're going to say it's my advanced cluster. That's the name of the cluster. So we can recognize our cluster from the list of clusters that we have created. That's the advantage of giving the cluster a meaningful name. And then the next option says termination protection, yes or no. If you recall, in EC2, when you set the termination protection to be true, that means you cannot delete that particular EC2 instance unless you turn the termination protection off. It basically is a mechanism to prevent people from deleting an EC2 instance. And so this termination protection is really a feature of the EC2 instance that's being propagated into EMR. By default, termination protection is on, which means you cannot delete the nodes. I'll go ahead and leave it at that level. Logging. It says, would you want this cluster to log all the outputs? It's by default enabled. I can turn it off, or I can turn it back on. Notice when you turn it on, it says where the log should be. Well, the logs should be placed under the S3 location. Well, the logs are actually created in the master, and then eventually it gets copied into S3. Well, where should it be? Let's go ahead and set it up. We want the logs to be in our own bucket. So I'm going to create a folder called logs. I already have logs for some of the other jobs that was created before. Let me go ahead and clean it up. So let me go to my S3 console, go to logs, and blow away the old directory. Done. Okay, so I'm going to say I would like to see the logs under my EMR demo bucket logs folder. That's where the logs will be placed. Okay, and then it says debugging enabled. Basically what that means is all the logs will be created, including the logs for the steps, and then all those files will be aggregated, and then you can actually search them through the management console. It allows you to search through the various logs. If you think about it, if your cluster has 100 machines, then all the logs that are created in each one of the machines, but you cannot be going around and looking at each one of those different machines and to see where your debug messages are for each of the MapReduce tasks. So what the EMR cluster does is it brings all those things into the master, and then eventually puts all those log files into the S3 location, and also makes it available for you through a console so that you can actually wade through the log files. Then there's also tags. If you recall, in EC2, you can tag an EC2 instance, and that's what it is. You can say my cluster is advanced. That's the key, my cluster, and advanced is the value. We can create up to 10 tags. These tags are propagated into the EC2 instances. We'll see that in a few minutes. Okay, then in terms of software configuration, it says, do you want the Amazon or the MapR configuration? If you choose the Amazon configuration, notice there is the EMR 410 and 400 release, which are Hadoop 2 releases. And then there are also the old AMI version releases that we talked about that you should not be using. That's the older versions, they're deprecated. Let's go ahead and choose the EMR 410 release. You can also go for the MapR. If you go for the MapR, you get M3, M5, and M7. These are the 3 editions that we have for MapR that is supported by AWS at this point. And then the latest version is 402. Let's stick to Amazon. That's what we would like to do. And then because it's advanced configuration, we have the opportunity to select any application we want. We have the opportunity to select Mahout, Spark, Oozy, whatever we want. So let's go ahead and try to add some applications. We're going to add, let's say, Mahout, configure and add. Notice Mahout was added. But you'll also notice that by default, it gave us Hadoop, Hive, Pig, Hue, and Mahout now. We can also delete something. I'm going to go ahead and delete Mahout. And instead, I'm going to go ahead and add Spark. See how easy it is to bring in an application on top of Hadoop. When I say an application, some kind of a data analytics tool built on top of the Hadoop Yarn platform. Okay, so we have that. And then we have software settings. That Hadoop has several properties, and those properties are available for you to configure in a Hadoop cluster. Since Hadoop software is being installed by AWS EMR, you have the opportunity to influence that configuration file. And so here is where you pass all the different properties, and there's a format to this. For those of you who are taking the Hadoop class and are viewing this lecture, now you see how you can use AWS EMR to configure your Hadoop configuration files. Okay, and then there's the file system configuration. Hadoop integrates with S3. S3 has security. You can have server-side security on S3 files or client-side security on S3 files. Right now, we chose no security, but the point I'm trying to make is AWS EMR gives you security. It allows you to store all the files in S3 and integrates it with EMR. You want the files in S3 to be secure, so it's giving you the security option. You can encrypt all the files in S3, the output files and also the input files that the job is using to process. You also have this concept called consistent view, which can be enabled or disabled. When it's enabled, what you're really saying is that when the AWS EMR cluster writes output into the S3, it should write in a consistent fashion. Usually it is non-consistent, which means when it writes the file will be visible even before the write completes. In this case, you're saying you want the AWS EMR system to write the file out, and only when the complete file is written out do you want it to be made visible for others to read. That's the idea. Okay, in terms of hardware configuration, notice there is VPC. You can change the VPC if you want. We're using the default VPC. You can create a new VPC. And it's important to run your Hadoop cluster in VPC because you don't want other people to have access to your cluster on the internet. Notice we talked about 3 different types of nodes: master node, core node, and task node. The master node, there's one instance of it. It's the M3 extra large. You can change the instance type. In terms of core nodes, there are 2 of them. In terms of task nodes, there is none. I'm going to go ahead and create, let's say, 3 core nodes and 2 task nodes. That's what I'm going to do. If you recall, the core nodes run the node manager daemon and the data node daemon, whereas the task nodes only run the node manager daemon, which means they only run tasks. They are pure task only. Okay, we've configured that. We can also configure the EC2 pair, so we can log into our cluster. And then there are other security groups that you can configure if you want. And then there is the bootstrap actions. We talked about bootstrap action. When the cluster is launched, there are some initializations that are done. In fact, you already saw some debug initialization was being done. You can create your own bootstrap action. You can say run a bootstrap action under certain circumstances. You can say if certain attribute is true or is set to true, then do certain things. So in that way, you can say if it's a master node, then run this bootstrap. If it's a slave node, then run this bootstrap. So you can do all kinds of configuration there. And then finally, you can also configure a step or as many steps as you want. We talked about configuring a step in the previous basics section. And finally, it says auto terminate. Would you want me to terminate the cluster, or do you want it to be running for a longer time? Let's say we don't want to terminate the cluster. Right, so we have done everything. Let's review. The name of the cluster is my advanced cluster. We want termination protection, which means we don't want the EC2 nodes to be deleted by mistake by the administrator. Logging is turned on. It's going to create all the log files over here in the S3 bucket. Debugging is also turned on. We have given the tag to be my cluster, and the value is advanced. We'll see that in our EC2 instances because the tags are passed to the EC2 instances. We chose Amazon EMR 410. We have Hadoop, HivePig, Hue, and Spark applications installed. We can change the configuration. I'm not changing any configuration right now. We decided to not encrypt the EMRFS file system, which is the S3 file system. EMRFS is the protocol that gets used to communicate with S3. In terms of hardware configuration, we decided to go with extra large for all of them, but we have 1 master, 3 core, and 2 task nodes. And then there's bootstrap actions, which we did not configure. Auto terminate, we set to no. Let's go ahead and create the cluster. The cluster is being created at this point. You'll notice that it's provisioning 1 M3 extra large machine for the master, 3 M3 extra large machines for the core nodes, and 2 M3 extra large for the task nodes. Don't forget, core and task nodes are slave nodes. Hopefully it's provisioning it. We haven't configured any steps, but there's the default setup Hadoop debugging step that it's going to have for all the nodes. All right, it's just a question of waiting. Let's go ahead and wait. It's been 5 minutes. It's still starting. The way I know the cluster has been started is when it actually comes to the waiting status, because we are running a long-running cluster. Once it comes to waiting, that means it's waiting for me to do work with the cluster. So let's wait until the cluster is completely up and the status is waiting. It's been 7 minutes. I'm going to pause until everything is up. Finally, after 8 minutes, it says waiting. That means the cluster is up. We asked for 1 master node, 3 core slave nodes, and 2 task slave nodes. So one of the first things that we want to do is go look at the EC2 instances and see if we did get 6 machines. It's just 9 running instances, but that's because I have a few other machines that are running. I'm going to say advanced. That was the name of the tag that we put in. Here are the 1, 2, 3, 4, 5, 6 machines that have been created. And if you click on the machine, you'll notice that there are tags within the machine. My cluster is advanced. All these machines have that tag. So these are the 6 machines which are our cluster machines. As you can see, EMR is built on top of EC2. So if you know how to operate EC2, you can manage the EMR instances. If I click on an instance and say terminate, notice it gives me a warning. It says that, are you sure you want to terminate this instance? This instance has termination protection turned on. That's the termination protection. It doesn't allow people to terminate an instance unless you turn the termination protection off. Okay, so as you can see, the instances are here. Let's go back to our cluster, EMR. Let's click on my advanced cluster. Let's look at monitoring. Look at all the different monitoring attributes that you get. You have your general cluster status. You have your node status. You have your IO status. You can change the period to be 1 hour ago to 1 day ago. It's a summarization, and also when it should end, how many hours ago it should go back. So this is your time period that you can set. I'm going to set it to an hours ago. You can have medium, you can have sparkline, different views to your monitoring. So where you're monitoring your cluster nodes. Okay, that's monitoring right there. In terms of hardware, notice we asked for 3 core instances, 2 task instances, and 1 master instance. We have all those things ready to go. If I want to interact with the cluster, I can surely do that. I can create a brand new job. You know how to create an add step. It'll go ahead and create the job and run the job for you. You're welcome to do that. I'm not going to do that right now. Okay, what else can we do with the cluster? Well, we can also log into the cluster. We can log into the master machine, which is where all the software for all the various applications are installed. Right, so which is the master machine? Let's go ahead and click on the view. That'll tell me what the master machine is. This is the master machine. So let me go ahead and do a Control C on that, or Command C, since I'm in Mac. I want to launch a terminal. Okay, so what I would like to do is log in to the master machine and see if I can interact with the cluster. Let me go ahead and get to my terminal. Here's my terminal. I'm going to say ssh-i /.ssh mrwhaler.pem. That's where my PEM file is. ec2-user, that is going to be the name of the user ID. And the reason we have EC2 user as the user ID is because this is an Amazon Linux machine. Here I am logged into the master machine. I'm going to do a clear screen. And then I should be able to type in Hadoop fs-ls/. That's my Hadoop command to look at the file system. As you can see, that's my distributed file system. It's got these various directories. I can interact with it to make a directory. Karthik. Well, why is it that I don't have write permissions? Well, that's because I'm logged in as a EC2 user. I should become the Hadoop user. So I'm going to say sudo su dash became root su dash Hadoop. So now I'm the Hadoop user. Now let me do Hadoop fs-ls/. That's the Hadoop command to list all the files in the root directory. Hadoop fs-mkdir/Karthik. I'm going to create a folder called Karthik and create that. Hadoop fs-ls/. There it is. I can create a file called file1.txt. This is file 1. This is line 1. Line 1. This is line 2. Save it. And I can copy the file into Hadoop. Hadoop fs-copy from local to /Karthik. The file will be copied. Oops, Hadoop fs copy from local. The name of the local file is file 1.txt, and I want to copy it into HDFS. For those of you who have taken the Hadoop class, you know what I'm doing here. I'm copying from the local file system. If I do Hadoop fs-ls/Karthik, it's listing the files. I can also execute the various Hadoop applications. For example, I can run Hive. I can say show databases. There's the default database, nothing there. I can quit. Oops, quit. Right, I can also run pig. Oh, by the way, if you're wondering why that exception took place, because I typed in the command incorrectly, queer. Okay, I can also run pig. For those of you who have taken the Hadoop class, you know how to run pig scripts. Quit. All right. Hopefully this gives you some idea as to how you can interact with the Hadoop cluster. Okay. Get back. So as you can see, we can create a cluster of machines and we can do our analytics so fast. We don't really have to install any software. That's managed Hadoop. That's Hadoop in the cloud. Right, let's do something interesting. Let's go back to our cluster, and let's say that we want to resize our cluster. We want to scale the cluster. Right, how do we do that? Let's go to our hardware, and let's say that we want to add more core nodes. Right, we have 3 core nodes. Let's resize it, and let's say that we want to change it to 6. We say 6, we're doubling it, resize, and now notice that it says 6 is requested, so it's going to go back and try to create 3 more instances. So we have a lot more instances now. That's how you scale up, by adding more nodes. We can also resize this. We can bring this to 1. Let's say we only want 1 task node. It says you're shrinking the size of the cluster, you're losing your capacity, but that's fine. We've added 3 core nodes. And the idea here is that if you have 4 nodes and if it takes you 2 hours to do the work, if you end up making 8 nodes, then technically it should take you only 1 hour to do the work. All right, so it's being worked on right now. If I go to the EC2 instances, I should be able to see the new instances coming up. And by the way, it's going to go through the same strategy. The tagging is going to be the same tagging. Also, there it is. These are the 3 nodes that are being brought up. You'll see the same tagging is taking place, and also the same kind of initialization. All the bootstrap actions will be run on all these different machines. Software will be installed on all these different machines. So all those things still take place on the 3 new machines that were added on the fly. This is where big data processing meets the cloud. The cluster is still ready to be used. It's just that those machines are coming up. Click on the cluster and click on hardware. It's still coming up. Refresh. The task instance group has been set to 1. One of the nodes has been removed anyway. It's easier to remove the nodes than to add new nodes. Removing the node is basically terminating that node. So that was done very fast. It's the resizing, which is adding 3 nodes, that's a little bit more expensive because you need to launch the machines, you need to install the software, you need to run any bootstrap actions that need to be run, which we don't have any, but it takes time to set that up, close to 5-6 minutes, as you may have noticed. It says core instance group 6 running. So everything is running at this point. Let's go back and go to our EC2 instances. Right, one of them was terminated. That's one of the task nodes. And we have the 6 core nodes running. Perfect. So we have 1, 2, 3, 4, 5, 6, 7, 8 machines running. Let's go back to our EMR. Click on our cluster. Click on hardware. 6 plus 1, 7 plus 1, 8 machines. Perfect. Now let's go ahead and create a step anyway. Let's execute a program. So it's add step. We want to run our word count program, and the jar location is going to be job. That's the program. Argument is word count minus D map reduce. This time I'm going to type it correctly. It's map reduce dot job dot reduces equals 2, and then I'm going to say where the input is. I'm going to say where the input is, which is data dash in And I'm going to say where the output should go to, which is data-out. Make sure the data-out folder doesn't exist. Yeah, it doesn't exist. Come back. Make sure that I spelled it correctly. MapReduce.job.reducers equals 2. That should be only 2 reducers. So there should be only 2 output files that will be generated. Okay, let's go ahead and say if something happens, cancel and wait. Add. So hopefully the job will run. Well, in this case, there are 3 input files. So there'll be 3 map tasks that'll be created, and there'll be 2 reduce tasks that'll be created. Let's wait for the job to complete. It would be fun if you have gigabytes of the data or even terabytes of the data, and you can use the power of this cluster to run a whole bunch of MapReduce jobs. If you want, you can even create your own input data, even simulate the input data, and then run your MapReduce program. The cluster state says running, which means the MapReduce program is running. It's waiting, that means it's done. Let me go ahead and refresh this. It's completed. Okay. So let's go back to our S3 management console. Refresh here. There's the data output folder. And there it is. There are 2 reducer outputs. So this time we did it right. All right. And in terms of logs, there's the job log. There's the steps log. We have a step ID, and that's the output of the step log. So if you wanted to see what the output files look like, it's already gzipped and placed right here. As you can see, everything is logged and copied into S3. Okay, so that concludes our advanced cluster configuration. So in this section, we did some advanced configuration in terms of cluster creation. We were able to scale our cluster, scale up by adding more core nodes. And also we were able to log into the master EC2 instance. And finally, we were even able to execute step, and we were able to demonstrate that we only had 2 reducers running in our cluster by setting the property MapReduce.job.reduces to 2.